virtual CISR seminar. This will be our very first for the spring semester. I hope you had started your semester well off, you've settled into your classes, and you are off to a great start. So today we have the great pleasure of having Dr. Upakar Bhatta from Central Washington University talking to us on machine learning for evaluation, governance, risk, and compliance. And this is associated with large language models. This is a topic that we have not had in previous CISR seminars, so I'm very much looking forward to it. Just to introduce, Dr. Bhatta is an assistant professor with the Department of IT and Management at Central Washington University. He just stepped in as the site lead for CISR at Central Washington University this year, and we are very much happy the way he has started and recruited students and getting the CISR program there going forward. Dr. Bhatta was an adjunct assistant professor of cloud computing at the University of Maryland Global Campus, and as an assistant teaching professor at Arizona State University before coming to Central. He has a Doctor of Science degree in cybersecurity from Marymount University, which he got in 2024, and his expertise and research areas are in application of machine learning techniques to cybersecurity and cloud security. He has extensive experience in industry before coming to Central, and he has worked at different levels within the cloud computing and networking and cybersecurity areas. So I am very much looking forward to what he has to share today. So you know how this goes. He will hopefully leave some 5-10 minutes towards the end for questions and answers. But as the presentation proceeds, if you have questions, you should feel free to put them in the chat. So we will monitor them and ask them at the end. And I also want to remind you before you leave that when the seminar ends, you would complete a survey that James will help us put a link in. So pay attention, engage by closely following along and putting your questions in the chat. And I don't want to take up more of your time, Dr. Bhatta, so please go ahead and get started.
Got it. Thank you so much, all. And first of all, I would like to thank you for your time this afternoon. And I hope this my research work is going to be a little bit of informative and helpful to all of you. With that, so let me get started. So would you guys able to see my screen?
Yeah, it looks
Yes,
good.
we do see. We do.
Okay, got it. All right, so my topic is machine learning to evaluate governance, risk, and compliance associated with large language model. So basically, I have an agenda here, a couple of, I have two phases. The first phase, I'm gonna a little bit outline the research background, related work, research methodology, and a little bit of an implementation flow. And the second half, I'm gonna be a little bit providing the responsible AI incident, and AI governance, and little bit embedding AI governance principle directly into the AI life cycle. All right. So we have a background of the study. Basically, as we see, there's a rapid advancement in AI technology. LLM is transforming business, how they operate, enhancing their operational excellence, reducing costs, right? Automation, efficiency. And with that, this increased use of LLM is basically introducing new governance, risk, a little bit of a compliance challenges, right? And the risk basically includes like, biases, toxicity, data sensitivity violations, and regulatory and non-compliance. And this work basically offers a potential solution to predict the risk associated with that LLM interaction. So this work basically integrates cloud services, machine learning, and data analytic services. And to train the machine learning model, I use the Azure OpenAI logs to build the data set. Okay. Now we have a rationale of the study. Previously, there are a couple of researchers they did explore the transparency for LLM, but they exactly didn't uh, perform the comparative evaluation of the compliance risk associated with that LLM interaction. That research was a little bit limited. And the machine learning framework was not actually implemented during that previous research, which was basically needed to evaluate the regulatory risk consideration. And also the existing research, they are not pretty much aligned with the NIST, risk management, AI risk management framework, NIST Service Publication 601, and I think 101 also. So they didn't align their work with that framework, which is basically for the AI governance and the risk management. Now, to fill in that gap, I am basically, my work basically integrate the machine learning pipeline to integrate how the machine learning can be applied to, uh, evaluate the risk associated with the LLM interaction. Plus, my work is pretty much aligned with the NIST AI risk management framework. Okay. All right, so let's move on. So there's a lot of, because this is the actual implementation, so we need to know a little bit of a prerequisite, cloud services. And now cloud services basically, NIST 840, 145 is on-demand network access to share the pool of, configurable computing resources, for the, sharing resources, managing resources, right? So now when we talk about cloud computing, so the actual implementation, we need to know exact services, what services we are leveraging to run the application upon the cloud. There are 3 services I mentioned here: infra as a service, platform as a service, software as a service. Now, so there are a little bit of difference in terms of their role. Now, when you talk about the services, we have a provider, cloud provider. They have their responsibility, and the customer, they have their own responsibility. There's a shared responsibility model. Now, if you look in infrastructure as a service, majority of the application data, runtime, middleware, operating system, that's customer responsibility, right? So they manage those things. But down below, there is virtualization, server, storage, database, networking. That's going to be the provider responsibility. So IaaS, basically customer have more that ownership compared to platform as a service, where provider get majority of responsibility. Customer only get the top application and the data, and then all other runtime, middleware, operating system, virtualization, server, storage, networking, all provider gonna be in charge of that. If you look into AWS, Elastic Beanstalk, that's the platform as a service. Now, software as a service, basically all the stack from application all the way up to the networking, application, data, middleware, operating system, virtualization, server, storage, database, networking, right? So all these things provider gonna be responsible to manage it. But still, the service is a shared responsibility model. So the data that customer, they're gonna put it on that service, they are in charge. So there's a joint responsibility there. Now, when we know the services, but the cloud security perspective, when the AI application they run up on the cloud, the security perspective we need to understand. So basically, cloud security, if you look in the there is like a physical security, right? Bare metal, server. You must have heard about type 1 hypervisor. They run directly on the top of bare metal, right? So these are the physical security perspective. Now, there is an infrastructure security. So now the virtualization, right? The container and other basically type 2 virtualization, that is basically you have a bare metal, there's a host operating system, and then there is a type 2 hypervisor, right? And then you have an application, bean, library, guest operating system. So those are the securities, the infrastructure security, basically. Now, the platform security perspective, you're going to be a little bit focusing on the incident and identity and access management, role-based access control. So those are the platform. And there is an application security perspective. There is a static application security testing, dynamic application security testing, right? So those are the application security that we, as a, like a developer or customer, they need to be well aware about that. Now, after application, there is a data security, right? So we want to make sure that our data is encrypted at rest, in transit, in use, right? So we want to make sure that proper encryption is enforced to protect our data that is in the cloud. Now, finally, after data is done, there is a governance risk compliance. That is the top layer. So we want to make sure that, whatever service we are leveraging, that is pretty much compliance with the organization compliance requirements. So those are the cloud security perspective. Need to understand that to be able to deploy the application upon the cloud securely. Now, there is a little bit of a prerequisite knowledge. Since this is the machine learning, so we should know at least how artificial intelligence. Now, we know that this is computer. It use like AI, to think like a human and perform function on its own, right? That's the AI, simple definition. Now, on the machine learning side, this is the application of AI that use algorithm to train the model to predict the pattern, hidden pattern. That is the machine learning application of AI. Now, the deep learning is a subset of machine learning that uses a neural network to mimic function of human behavior. Basically, that's a simple definition. And generative AI is a subset of deep learning that is used to create a content, right? We all know that. And agentic AI, we must have heard this agentic AI news, right? So agentic AI is basically the subset of generative AI that is used to automate machine learning workflow, AI workflow, right? And the large language model is also subset of generative AI that is used to create a text, image, video, right? So those are the basic, knowledge that we need to know about this, AI, subset of AI. Now, the related work, previously, there are a couple of studies been done to explore transparency for LLM. But like I said before, there is a implementation, machine learning implementation to evaluate compliance risk associated with LLM interaction was limited. Now, there was one researcher, Zhang, 2010. He basically did a little bit of research on mechanistic understanding of how the model or system functions by disclosing its component and processes, but he didn't actually implement it in the real-time scenario. Rasam 2011, it is basically did the same thing, but it was a little bit more the human-centric approach. That was pretty helpful for the transparency perspective, because we, like a machine learning model on the back end don't have much visibility. There's the black box side. So this human-centric perspective was pretty much helpful for the governance perspective. Now, 2019, Karras basically, explained little bit of a further explanation of machine learning and AI output, to mitigate transparency-related challenges. And recently, 2024, John basically emphasized the explanation of AI system, which had been identified as a contributing to the greater system transparency. So transparency is a key. We have a tool SAP that is basically used to provide more transparency. So this was the previous related work. Now this work, basically there are a couple of things that since this is the experimental work, and I use the modular machine learning pipeline that includes the components such as feature abstraction, model architecture, and evaluating the accuracy of machine learning for GRC. Now, the first thing, we all need data, right? Machine learning basically use data to train the model. So now how you collect the data, it depends. So now I use the Azure OpenAI service, 5,000 records, and the features including there's a response time, model type, token-based, there's a data sensitivity, a bias score, and toxicity score. So those are the key features that is used to train the model. Now, when we do the data collection, there is a little bit of a data pre-processing, data cleaning, encoding, making sure that we are properly converting the categorical data to the numerical value, and then make sure that numerical value is scaled properly to ensure uniformity across the features. That is done by normalization, right? And exploratory data analysis, basically, this is a data visualization technique. We want to make sure that, before we train the model, the data is not like a imbalance. Data is not biased, right? So we want to have that sort of visualization. And during this process, a lot of machine learning folks, they perform threat modeling on this phase, EDA phase. The reason they do threat modeling is to discover any sort of vulnerability during the design phase of AI, right? Threat modeling. So, and once they done, EDA, then we'll make sure that there is a proper, data set divided into training and testing. So here, 80% training, 20% testing set. And there is one technology, synthetic minority oversampling techniques, being used to mitigate any sort of class imbalance in the data set. It provides the better accuracy, reduce any sort of bias. And then the algorithm, basically we have a supervised, unsupervised algorithm. Since this is based on the labeled data set, so supervised algorithm being used, but LLM basically use the supervised, unsupervised, and reinforced, algorithm. It combines those things. All right, so now this is a little bit of a pipeline. So if you look in here, machine learning model, you need a data set, data pre-processing, splitting a data, and build the model, supervised, unsupervised algorithm, right? Predict the output, find the accuracy, and evaluating the model. Now, on the black box foundation model, LLM, which we basically don't have that visibility, only developer. From the customer perspective, they wouldn't have that visibility, right? That's why there is a little bit of a risk, a transparency risk. On the developer side, they would have that visibility. They do, use the data set, and they, based on that data set, they train it, make sure they validate that, and then they evaluate it before they provide the output. But for the transparency, we need to have proper tool to make sure that all the workflow is visible to avoid any sort of risk, governance risk. And there is a little bit of an output here. So model accuracy is basically, did apply SMORT to mitigate class imbalance issue, right? And here is a confusion matrix. We have, this is a true positive. This is on your, bottom right corner, true positive, and the top left corner, true negative, right? And here, this is the false positive, and this is false negative. Now, this accuracy is basically based on this. So accuracy equivalence, true positive plus true negative divided by all of them. True positive, true negative, false negative. And based on this confusing matrix, random forest algorithm is a little bit above, almost like a 75% accuracy compared to all other. And this algorithm, supervised algorithm, is pretty good. It resolves any sort of overfitting issue, and you basically don't have to map all the features. This is pretty good on that side. So these are the output random forests. Now on the deployment side, now once you have the model ready, so you want to deploy it up on the cloud. You want to save that model and then deploy securely using CI/CD pipeline. So the platform as a service is Azure App Service. Basically, I use that to deploy this work, this machine learning application. Now, once you save the application, you want to push it to GitHub, right? So that phase, basically this phase, you want to perform the threat modeling again to discover any sort of vulnerabilities. Now, once you push it on the GitHub, then Azure, DevOps, it triggers, right? And build, deploy the application. So you push the code to GitHub, Azure DevOps pipeline is triggered, and then Azure DevOps run continuous integration, CI, to build and test. Now, and then after CI is done, there is a continuous deployment. So you deploy your application, it basically deliver the application to the Azure App Service, which is platform as a service. Now, during the CD, it is extremely important to perform dynamic application security test. That's like a little bit of a pen testing. So this is to discover any sort of vulnerabilities again. And once you deploy to Azure App Service, then you pretty much get the URL, and then you can access your application. And this is the workflow here. These are basically your repo, and then these are the file data. You have a training and testing CSV, and you have basically on the model PI, you saved it here, and then all this, your GitHub. All right, so let's move on. That was a little bit of an implementation side. Now on the actual, the most of the AI incident risk happens after the deployment. So that doesn't mean that you should not be, working on finding the risk and mitigating the risk during the implementation phase. You should do that. You should perform threat modeling. You should perform threat intelligence. You should perform risk assessment. But after the deployment, there is a governance. There is a governance. And during the implementation phase, you also need to implement that governance into that phase. I'm going to walk you through that also. But here, this is the real. Yesterday, February, not yesterday, day before yesterday, February 1st. This is the incident. Now, basically based on OECD AI newsletter, 82.6% of email phishing now use generative AI. It's creating a highly realistic fake test, voice, videos, very difficult to detect, right? So increasing cybercrime. So that was reported on February 1st. And if you look at this graph, this is the AI incident from 2012 all the way up to 2023. The incident is increased, right? So it's rapidly increasing, meaning there is a strong need of AI governance, responsible AI, because after deployment, this incident going to happen. And then if you look at the recent 2022 to 2025, still the risk the AI related risk is incident is increasing rapidly. Okay, so this is the latest report from OECD, European Organization of Economic Cooperation and Development. All right, so why would you need to deploy the AI safely to prevent those sort of incidents? Now, responsible AI is basically, there are a couple of principles here. You want to make sure the accountability, whatever we deploy, we as a developer, we are accountable for any sort of like a risk. And we are focused on the safety, technical robustness, making sure all the data is secure. In USA, there is a state regulation and there's a federal regulation. You want to make sure that data is, confidential, private, sensitive, public. That is the state, and the federal top secret, confidential, unclassified. You want to make sure that you follow that a requirement, making sure that your AI model is pretty much transparent. How you train the model, right? What are the tuning, tuning? What are the tuning mechanism you are implementing, making sure that your data is not biased, right? It's fair, and making sure it is for the environmental well-being. These are the little bit of a responsible AI. Now, how we gonna achieve this? The only way we can achieve this is embedding AI governance principle directly into the AI lifecycle. Like I showed before, we have a data, we have a pre-processing, we have a EDA, and we have a model, we have a evaluation, right? So when you collect the data might be biased. Data might need some sort of cleaning, right? So you want to visualize whether that data is fit to train the model or not. If you believe, 45 to 60% of data scientists, they spend their time, majority of the time, it's just the data collection, cleaning, those sort of making sure that data is properly ready for the training. Now, once you collect the data, there is exploratory data analysis. That's the next phase. You want to make sure, you want to understand the bias, whether data is balanced or imbalanced, is there is a quality issue. You want to visualize that thing, right? Data analysis. Now, during that time, you want to perform the threat modeling to discover any sort of issue, right? Now, this is the AI governance during the AI development phase. But the incident I showed you previously, that is the AI deployment phase, governing AI during the deployment phase, meaning that you also need to, when you need to embed AI governance into AI lifecycle, you want to make sure that during the AI development phase, you are governing, you are doing all proper things here. Now, once you do EDA, the next thing you want to make sure that you pre-process, data cleaning, like any missing value, fix that, and then normalization. Basically, you want to normalize. When you have a categorical data, you want to convert it to the numerical data, and making sure that numerical data is scaling properly to ensure uniformity across the features. That's the normalization. And encoding is basically, converting categorical data to numerical data. And fairness, biases, you making sure that if you have an imbalanced data, you have a proper tool, SMOTE, synthetic minority oversampling techniques. You can implement it to, mitigate class imbalance. Now on this, and then once you have this process, the next thing you do basically feature extraction. You want to select the proper features that can be used to train the model. So I did 9 features, including biases score, toxicity score, sensitivity, right? Those are the key features that I would like, to train the ML model. And then once you select the features, you want to make sure that you are training the model based on the whether, supervised or unsupervised, right? So labeled data set, supervised, unlabeled, unsupervised, and then LLM, combined, supervised, unsupervised, reinforcement, right? So these are still the governed AI development, right? Now, pre-deploy, so risk assessment. So during the model training and evaluation, you need to perform the risk assessment. Why would you need risk assessment? For things. You want to identify any sort of vulnerabilities, first thing. You want to analyze those vulnerabilities, right? So during the analyze phase, there is organization sometime, there is a risk. They can, they want to make sure that, they are properly mitigating those risks. To mitigate risk, there is a, security is a cost, right? That you want to make sure that you are properly providing the metrics like single loss expectancy, asset value, exposure factor. This is a little bit of a cybersecurity side. Annual loss expectancy, single loss expectancy, and annual rate occurrence. So these metrics help manager whether they should mitigate the risk or avoid it, right? So you need to analyze it. And the third thing, you want to evaluate those risks. And evaluation basically, and then after that, you provide a treatment, whether you want to accept it or avoid it or transfer it or mitigate it, right? And based on the treatment, you follow the policy, design the control, and then implement that control to mitigate that thing. So this is the risk assessment. It's very important during this phase. And pre-deployment impact assessment. Before even you deploy your AI, you need to perform impact assessment. That is basically whether, based on the risk assessment, you perform impact assessment after risk assessment. But sometimes, the European, they do impact assessment and perform risk assessment. But the right approach, based on the other standard NIST, 601 and other, follow the risk assessment and then impact assessment. This also during the governed AI deployment. And once you're done with this, so you are ready to deploy, right? So deploy AI, and then you need to monitor that, right? Threat intelligence. Like, when you do the cybersecurity, you deploy the tool and use the Microsoft, Sentinel or MS Defender for cloud, right? Those are the monitoring tool to discover any sort of vulnerability. So that is the threat intelligence side during the deployment phase. All right. So now, after you, done with the development, so now how you gonna govern the deployment phase? So this is the very, very important. All right. So we as a, you as a student, might be leveraging ChatGPT, Copilot, I put it here, right? Grok, Azure OpenAI. So how do we make sure that the request you are putting in is the legitimate, is not the harmful, not something, that damage the reputation, those sort of things. So there is a policy. Every organization, university, they have a policy. And based on that policy, the faculty, student, they follow that policy and making sure that, they are doing the right thing. But how would you implement that policy? And how would you basically proactively block any sort of malicious behavior? That is the key goal here. So middleware, once you have the policy, you want to create a logic. So policy says that, we should not be using ChatGPT to perform our assignment, to submit our assignment. So you create a logic, and then a student, if, or the faculty, if they are grading, using ChatGPT, there is a logic, you can't do that, right? So if they put in something, it will be blocked by middleware. So this is user upload the logs basically and Flask backend process, and then provide a recommendation, and basically that recommendation is returned to user via middleware, making sure that the proper policy is implemented. So if you look in the AWS, they have a pretty good generative AI chat application using Amazon Bedrock. Is a fully managed service. They are using that the model, AI model, and the middleware they are EC2 instance. They are basically creating a logic, allowing user to use the, AI properly, and the front end S3 hosting the static website, allowing user to interact with the AI model. So this is basically, so organization, they put that, middleware, and then user, they use this, all the AI application middleware goes through middleware and then goes to the AI provider. Middleware is the basically, has the logic. So based on that logic, user gonna get the response, whether they are allowed or denied, So those are the little bit of a, deployment phase. And governance framework, basically, when we have pretty much, regulation, standard, policy, and procedure. Now, let's say, university has an AI governance framework. And based on that framework, they are creating a policy for the faculty, for the student, right, for the other external stakeholder. And that policy, they have it, right? So now they want to automate that policy without, making sure that all the AI application follow that policy. And if they do something, that is against that policy, that request should be immediately blocked. How would we enforce this? Middleware, create a logic based on that policy, and then put it on your enterprise environment. And then whatever request coming from the user internally, it goes through that middleware, and then finally reach out to the AI, the vendor, get the response. Middleware gonna block it, allow or deny, and the user gonna get response back. So this is the key aspect when creating an AI policy: trustworthy characteristics, ethical use, which basically includes, valid, safe, and accountable, making sure that, all the process, this, government framework, middleware, all the rules, they are transparent, explainable. If somebody, faculty, why we're not able to get that response, they should be able to have some sort of explanation that, this is against the policy. And the policy is basically built upon the framework, and framework is to meet the university compliance requirement. So that should be pretty transparent, explainable, that we all, are on the same page. So basically, NIST AI risk management framework. This is pretty much helpful. There's ISO 2001. These are the framework you want to align your workflow, making sure that they pretty much aligned with the map, manage, and measure. Now, LLM behavior, this is identify AI capability and role. So you want to map that features to NIST map function. And the GRC attribute, you want to making sure that you are aligning those attributes to the NIST govern, embedding organization policy, risk, and compliance. And then there is a little bit of a measure and manage. So you are, this is basically for the risk prediction. So those are the framework that is adopted by the, some of the university industries, it's pretty good framework for federal and local agencies. So yeah, so that was it. And if you guys have any questions, feel free to chime in. And then, yeah, thank you for your time.
Thank you very much, Dr. Bata. That was a great walkthrough of the process, very much like what a data science process would look like when you have to start from raw data and get to a place where you would extract knowledge and information from it. And so there was a number of interesting things you said, focusing on governance, risk, and compliance issues. And I'm sure there will be some questions for you. And I'm happy that you were able to leave out some time for discussion. So if anybody has questions, you can unmute yourself and ask, raise your hands, whatever is easy for you to do. Is somebody speaking? was somebody trying to ask? So if you want to give a sign, you could raise your hands, but I would be perfectly fine if you unmute yourself and ask.
Hi, I have a question.
Sure, go ahead.
Dr. Bhatta. So like you mentioned, you talked about NIST, and that's like the U.S. regulatory standards, for technology, I believe. What happens with like when it comes to other nations? Because all other nations, they have different codes of ethics and frameworks. Are during the development phase, are these uh companies supposed to make LMs apply to all of the regulations, or how do they pick and choose which regulations to listen to from different nations?
So this is basically European. They have their own standard, Organization Economic Cooperation and Development. And if you look at the privacy perspective, they have a GDPR that was for European standard, right? 2018. So we have USA California Consumer Privacy Act that was developed back in 2020. So basically, what industry here they do, they basically incorporate both, the standard, making sure that is safe for the customer, keeping their data safe. And in the USA, we pretty much aligned with the NIST federal, 853 for the control, and for the AI, 600 or 100 NIST, right? So NIST is the widely recognized framework in USA, and then European, they have their own standard there, and they are stricter. They are strict. Yes, yes, yes. So we want to make sure that we are basically incorporating those standards for the safe deployment, I guess.
Okay, so are the AIs like different then? Like, is like would like ChatGPT in US be different than Europe because there's different standards, or do they
No.
develop them the same?
So basically, they have to follow their regulation before they deploy that application over there, because they need to meet their standard as well. So I built an AI and I want to deploy it for the UK customer. So if I don't meet their compliance requirement, they won't allow me. So we need to follow there. Otherwise, they might block it. So,
Mhm.
there are a lot of things that they are blocking, right? So yeah,
Yeah, that makes sense. Thank you.
you're welcome.
So while somebody thinks of a question, Dr. Bhatta, I want to ask on the NIST question to just follow up. I know about the NIST standards and for cybersecurity, and more recently there is the NIST Cybersecurity Framework 2.0,
Yes.
which much would kind of consider AI implications in particular and privacy and things like that. So when you were making references to NIST, were you particularly thinking about NIST Cybersecurity Framework 2.0, or maybe your approach doesn't necessarily have to stick to that? What are your comments
That is
on?
a very good question. So, yeah, NIST 2.0, that is the recommended approach, and that would provide not only the features that was previously, used to address any sort of risk, plus incorporating new features that might be beneficial to mitigate evolving risk. And it is one thing, Dr. Asabu, this is managing evolving threat is a challenge, is a great
Mm-hmm.
challenge. So we all,
Yeah,
work together. So yeah.
great. Anybody has got any questions?
I have a quick question. Can you hear me?
Sure, go ahead.
So I was wondering, out of the NIST framework, which policy or policies would you say is the most relevant to the average person working with AI, or working on a project or something? Which thing would they really have to look out for, most likely?
So most likely, if they are working for AI, there's like I mentioned, like impact assessment and a little bit of AI information, right? So NIST 601, that is the AI risk management framework. There's a NIST 101 also. That is the very helpful for AI risk management. Now, ISO 42001, that is pretty good for AI information management. But there is a ISO 42005 for the impact assessment. So these are the good standard framework for the safe deployment of AI. And then they also, because we know the federal organization, they have their own existing asset and they want to run their application within that existing asset. And they want to make sure they follow the NIST 853 guidelines, the control to protect their existing asset. So that's there also.
Thank you very much. We only have a couple minutes left, so I think it probably would be a good idea to wrap it up here. Thank you very much, Dr. Bhatta, for that interesting presentation. We would like you to send us the slides so we can post it on the CISR website, and we'll reach out to you about that. Students, if you haven't completed it, the survey link, James must have put it 5 minutes ago or so. Take the time to complete that, give us feedback on this. The next CISR seminar will be 2 weeks from today, and we will hear from another speaker. And every now and then, there may be weeks where we would have a virtual presentation from the Viceroy program nationally. And so there was one the end of January, and many of you attended on scholarships that are specifically about cybersecurity and related to the Department of Defense. And there will be another one now in February that will be on professional skills on how to handle interviews and things like that, that I think is very valuable. So we consider them as things that would count to your activities related to seminar attendance, just in the same vein as we do this regular CISR seminars every other week. Whenever that happens, I would encourage you to attend them. They typically happen on a Wednesday, late in the evening, and should be okay for you to squeeze in time and attend. So I want to encourage you to do that. Otherwise, follow along things when they are announced on the Canvas side of this, which we found very useful. And so there is plenty of information that comes every now and then there. So keep an eye out for those and keep up the good work that you're doing. Enjoy the rest of your day, and we will